another problem where we take the same induction motor, that is 460 volt, 25 horsepower, 60 hertz, 4 pole star connected induction motor. Now we do have the same equivalent circuit parameter, but now we would like to calculate what is the maximum torque of this induction motor. Now, at what speed and what slip does this maximum torque occurs? Because we know that the induction motor does have torque slip characteristics which are somewhat similar to this. Now once you have this torque slip characteristics, we wanted to know this is what is slip for us, and this is where we have slip equal to 0, and this is where slip equal to 1, and this is what is torque for us. Now in these characteristics there is a maximum torque, is what we call it as T max, and now we wanted to know what is the slip corresponds to that T max, and at the same time what is the speed that corresponds to the maximum torque. And also we would like to calculate what is the starting torque for this particular induction motor. So these are somewhat related to the torque slip or torque speed characteristics of the induction motor. And then suppose if you double the rotor equivalent resistance or rotor resistance from 0.332 ohms to, let's say, 0.664 ohms, then how does this torque slip or torque speed characteristics are going to change? So that is what we are going to solve in this particular problem and understand how this torque speed characteristics does get influenced by the slip or the rotor resistance is what now. If you wanted to calculate the maximum torque of this induction motor, first we need to know at what slip or what speed that induction motor maximum torque occurs. That is nothing but the condition for the maximum torque. Now if you look back into the equivalent circuit, this is the rotor resistance, which also indicates the load that is connected to the induction motor. If you can get the power that is given to this particular resistance to be maximum, then that also implies that the amount of torque that you are getting as an output is also maximum. Now, to know the condition for the maximum torque, we would like to have the condition for the maximum power. Now, if you want to have the condition for the maximum power, then we will try to first represent this equivalent circuit on this side of the stator using a voltage source in series with resistance and reactance, is what we call it as a Thevenin's equivalent circuit. How do we get that? So now if you look at this particular equivalent circuit, so this piece of the circuit has to be represented by a Thevenin equivalent circuit. For that we need to consider that this is our load. Now remove that part, then you will be able to get open circuit equivalent circuit, because V Thevenin is nothing but V open circuit voltage. What is to be opened? You have to remove that load and see how much will be the voltage across those two terminals. So now if you remove this particular load for us, then try to observe the voltage between those two terminals. So this is what is the voltage across these two terminals is nothing but the Thevenin's voltage for us. In order to calculate that particular voltage, we say that if you know the value of V phase, V Thevenin is nothing but the value of the current flowing in the circuit, if you know the value of the current as I, multiplied by the value of the reactance. Now if I say that the current flowing in the circuit is V phase upon the value of the total impedance, that is nothing but R1 plus jx1 plus jxm. So this is what is the value of the impedance. As we wanted to know the value of the magnitude of the V Thevenin, then you can say that the square root of real part square and imaginary part square. This will give us the value of the current, and multiply that with xm, then we will be able to get the value of the Thevenin equivalent voltage. So simply we are calculating the current that is flowing in the circuit and multiplying that with the value of xm. as we are concentrated on the magnitude of that voltage, we are not worried about the angle of that voltage. We are just taking the magnitude of that current as well as the magnitude of that reactance. Now we know the values of all these reactances and resistances along with the phase voltage. You need to remember that the phase voltage is not going to be 460, it is going to be 460 upon root 3. If you substitute that, then we'll be getting that V Thevenin voltage as 255.2 volts. And after that, we wanted to get the Thevenin equivalent impedance. That is nothing but the equivalent impedance between those two terminals when your voltage sources are short circuited. So now when you short circuit your voltage source, between these two terminals, what is the value of reactance you have is nothing but X Thevenin reactance. Now in order to get, it's not going to be just X, it is going to be Z Thevenin. Now Z Thevenin indicates that your value of JXM is in parallel with R1 plus JX1. So these two impedances are connected in parallel. Now if you try to simplify that, means substitute the value of XM, we know that the value of XM is 26.3, the value of R1 is 0.641, value of X1 is 1.106. So if you substitute and consider the parallel combination and simplify those numbers, then we'll be able to get Z Thevenin as 0.59 plus J 1.0752. So this is what is Z Thevenin. That is indicating that you can replace whatever the equivalent circuit that we have on the stator side along with JXM with a voltage source in series with an impedance, and the value of the voltage source is 255.2 volts and the value of the impedance is 0.59 plus J 1.0752. If you do that, then your resultant equivalent circuit, once you replace your stator circuit with JXM by a voltage source in series with an equivalent impedance, we now calculated those equivalent impedance, then this will be your equivalent circuit. In this Thevenin equivalent circuit, our whole objective is to have the power delivered to the load resistance to be maximum, because that particular condition where the power delivered to your load resistance to be maximum is nothing but the condition that gives you the torque value to be maximum. So that is why we will try to get that condition, and that condition happens when your source impedance is same as your load impedance, and calculate that and get your conditions for the maximum torque as well as maximum slip and maximum speed. And these are the expressions that we actually derived during our class section, where we got this slip maximum to be expressed this way. So now once you considered the maximum power being delivered to your load resistance, and that condition occurs when your slip is equal to this particular value. Now in this equation, you know the value of R2 dash, which is 0.332, and R Thevenin, we have that value as 0.59. X Thevenin value also we have 1.0752, and X2 dash also we have it as 0.464. If you substitute all those numbers, the value of S max, or the slip at which you get maximum torque, is going to be 0.198. This is the slip at which we get maximum torque. And now once you get the value of slip, then you can calculate the corresponding speed, because slip is available and we know the synchronous speed which we already calculated in one of our previous problem. So then it is 1 minus 0.198 multiplied by 1800 rpm will give us the speed at which you get maximum torque, that is 1444 rpm. So this is the speed at which you get maximum torque. And now if you wanted to know the value of that maximum torque, or the particular value of the torque, you can get using this particular equation. Now we know the value of V Thevenin, which we calculated, and we got it as 255.2 volts, and omega synchronous, we have that as 188.5. We calculated that in the previous problem. And R Thevenin is 0.59, R Thevenin is 0.59, X Thevenin is 0.1.0752, X2 dash value is given as 0.464. If you substitute all the numbers in this particular Tmax expression, we will get the maximum torque as 229 Newton meter. So this is indicating that if you have your torque speed characteristics, then this particular slip is 0.198 and the speed that corresponds to this is 1444 rpm. The value of the torque that you get here is 229 Newton meter. So this is what is the way we have our torque speed characteristics and the condition for the maximum torque. And next thing is to calculate the starting torque of the motor. As I said, this is what is going to be the starting torque of the motor. Now if you want to calculate the starting torque, that is where you substitute your values of slip equal to 1. So now if you consider that your value of slip is equal to 1 in your torque expression, then you will get your starting torque. That also can be easily calculated using the values that you have in your Thevenin equivalent circuit, where V Thevenin we know that is 255.2, R2 dash we already know that the value as 0.332, and substitute the synchronous speed values and all the reactances. Then we'll be able to get the starting torque as 104 Newton meter. So this actually gives us a clarity that the starting torque is 104 Newton meters and the maximum torque that you have is 229 Newton meter. Slip at which it occurs is 0.198. The speed at which it occurs in 1444 rpm. So this is what is the torque speed characteristics of the motor in this particular case. Now the next problem, the last one, is what if you double your rotor resistance? Now if you double your rotor resistance, you can see, and we also discussed in our lecture, that the maximum torque is not at all depending on the value of the rotor resistance. So when your rotor resistance is doubled, now we know that the maximum torque is not at all depending on the value of the rotor resistance, whereas the slip at which that maximum torque occurs depends on the rotor resistance. So if you calculate that slip at which the rotor maximum torque occurs by substituting that R2 dash value as double the value of resistance that we have, that is 0.664, then we will get the slip that corresponds to the maximum torque as 0.396. That will be exactly double to that of the slip that we have in the previous case. Then the corresponding speed that you get is 1 minus 0.396 times of 1800 rpm is going to give us the value as 1087 rpm. And next, if you calculate the corresponding Tmax, Tmax is not going to change, and that's going to be 229 Newton meter. We know that the maximum torque value is not at all depending on the value of the rotor resistance, but the starting torque do depend on the value of the rotor resistance. So if you substitute it and calculate, that is going to be 170 Newton meter. The same characteristics for both the cases, when you have rotor resistance to be 0.332 ohm and also rotor resistance to be 0.664 ohm, are given in this particular characteristics. If you try to properly observe these characteristics, you can see that whenever the rotor resistance is doubled, then you have the maximum torque that is occurring at a slip of 0.396. Whereas for the original value of the rotor resistance, you have the slip at which the maximum torque is occurring as 0.198. Now we know that the corresponding speeds will be different. Here our speed is 1087 rpm and this is 1444 rpm. Whereas the starting maximum torque value is 229 Newton meter in both the cases. Whereas when you double the resistance, the value of the starting torque was a little higher, it is 170, but in the original case, the starting torque that we have is 104 Newton meters. So this is the problem where you will be able to understand how your torque speed characteristics or your torque slip characteristics are changing with respect to the value of the rotor resistance. As you increase your rotor resistance, because you have 0.664 in this case here, and whereas this case is 0.332, as you increase your values of the rotor resistance, your maximum torque at which the slip at which the maximum torque occurs is increasing. You will be moving towards this. So you are expected to get this kind of characteristics as you increase your values of the rotor resistance. So this problem gives us an understanding on how your torque speed characteristics are really changing with respect to the value of the rotor resistance, and how do we get the conditions for the maximum torque with respect to slip as well as